In this video, we'll be looking at composite functions, but before we do that, we have to look at a few things first. So in the previous videos, we learned about functions. A function f of x, set of rules that outputs a value when given a value of x. So we want to try that out. For example, if we have f of x equals x squared plus 1, and we see find f of 3. How do we do that? It means that we've been given an x value of 3, so wherever we see x, we replace it with 3, and that's 3 squared plus 1, and that gives us 9 plus 1, which is 10, meaning that f of 3 is 10. For the same function, we can find f of negative 2, and that will be negative 2 squared plus 1, which will be 4 plus 1, which is 5. f of negative 2 being 5. Let's try another function. f of x equals 3x squared minus 2x plus 1. And we have to find f of 1. f of 1 will be 3 times 1 squared minus 2 times 1 plus 1. This is going to give us 3 minus 2 plus 1, giving us 2. So f of 1 is 2. f of 0. f of 0 will be 3 times 0 squared minus 2 times 0 plus 1. This will be 0 minus 0 plus 1, which is 1. So f of 0 is 1. Sometimes we will be given the function value and asked to find the inputs or the x value. For example, if f of x equals 5, find x if f of x is x squared minus 6. In this case, this is what we do. We've been given the value of y, or the value of a function, and we have the function too. So we want to find the inputs that we are supposed to put inside to give this output. It means that f of a certain value x is giving us x squared minus 6, and this results in 5 functional value, meaning that x squared minus 6 is equal to 5. So that x squared minus 6 minus 5 is equal to 0. X squared minus 11 will be 0. X squared will be 11. And x will be taking square root of both sides, plus or minus square root of 11. That is a solution. Let's take another function. f of x equals x squared minus 4x. Find x if f of x is equal to negative 4. It means that f of x is x squared minus 4x, which gives us negative 4. So therefore x squared minus 4x is equal to negative 4, and x squared minus 4x plus 4 is equal to 0. We can factorize this out and get x minus 2 multiplying x minus 2 is 0. X minus 2 squared is 0. X is 2. Yes, so this, we have this, x is equal to 2. X is equal to 2. Sometimes you'll be asked to find the functional value but you won't be given a number. You'll be given another expression. For example, if f of x equals x squared plus 1, find f of x minus 2. It's just similar to what we just did. You see that we can have, in the previous questions we had f of x equals find f of 3, and you were given f of x. Here we are finding f of x minus 2, and we've been given f of x. Wherever we saw x, we replace it with 3. So the same thing is what we do here. Wherever we see x, we replace it with x minus 2. So that f of x minus 2 is going to be x minus 2 all squared plus 1. So x squared minus 4x plus 4 plus 1, which will be x squared minus 4x plus 5. F of x minus 2. Let's try another question. If f of x equals to 2x plus 1 over x plus 7, find f of x minus 2. The same thing, we just fix in x minus 2 wherever we see x. So f of x minus 2 is going to be 2 times x minus 2 plus 1 all over x minus 2 plus 7. This is going to result in 2x minus 4 plus 1 all over x plus 5. This will give us 2x minus 3 over x plus 5 for our value of f of x minus 2. Sometimes too, we are given a function of an expression and we are asked to find f of x or a function of another expression. For example, if f of x minus 1 is equal to 2x plus 7, find f of x. In this case, the question has been reversed, but it's still solvable. What we do here is that we look wherever we see x minus 1, we put x. So x minus 1, we put x. If we are putting x wherever we see x minus 1, then what we put in place of x? X minus 1 is x. So x minus 1 plus 1 is going to give us x plus 1. So it means where we are seeing x, we are putting x plus 1. If we put x wherever we see x minus 1, then it means we are putting x plus 1 wherever we see x. You can just make this x the subject and just bring this here. You get it. So that f of x will now be 2 multiplying x plus 1 plus 7. That will be 2x plus 1 plus 7. 2x plus 8. Let's try another one. If f of the expression x plus 4 is equal to 2x minus 3 over x, find f of x minus 1. What we do is that x plus 4, x minus 1 means x will be x minus 1 minus 4, x minus 5. So in place of x, we put x minus 5 inside. So that f of x minus 1 is going to be 2 x minus 5 minus 3 all over x minus 5. So that f of x minus 1 is going to be 2x minus 10 minus 3 all over x minus 5. This will result in the production of x minus 1 being 2x minus 13 over x minus 5. Try these few questions on your own and let's see how well you do. So these are the questions. You can try and solve them on your own. Pause the video and solve the questions. Afterwards, you can check the solution and see how well you did. Afterwards, then we solve the composite functions. Move on to the composite functions. So these are the solutions. You can check and see if you answered all correctly. If not, you can go through the video again and look and try and understand it better, or look through your solution and find the errors. You can comment if you had the correct answer. If you didn't, let us know. Let's quickly move on to composite functions. Composite functions. We are not going to be doing all of composite functions today in this video. So we'll introduce composite functions 1, and then there will be another video to continue or complete composite functions. This will just be the introduction of composite functions. So a composite function is a function of a function. A combination of functions is what we call composite function. So if I have, for example, if I have a function f of x and another function say g of x, f of x is the result of the value x on a function. So I can input this result into another function as its input, and I can have g of f of x, meaning that f of x output becomes the input of g of x. We can write this conventionally as g of f of x. Again, we can have other functions. We can even have g of f of p of x. We can have as many as we want. It's just how we are relating functions. Composition of functions is inputting the result of a function into the inputs of another function. That is just basically composite functions. Let's take note that we can also add functions, subtract functions, to perform basic arithmetic operations on functions. For example, we can have g of x plus f of x. So for example, if g of x is x squared and f of x is x cubed plus 2, you can add g of x and f of x, and it will give us x cubed plus x squared plus 2. There's a new function attained from the sum of two functions. So yes, we can attain functions by performing operations on other functions. We can also subtract them. G of x minus f of x would have been x squared minus x cubed minus 2, which would have been another function. We could have multiplied them. X squared multiplying x cubed plus 2 would have been x to the power 5 plus 2x squared. This is also another function. We could have even divided them, giving us x cubed plus 2 divided by x squared. This would have been x plus 2 over x squared. Also another function attained by performing operations on two different functions, g of x and f of x. Even if it was the same f of x or the same g of x, you can add g of x to g of x, f of x to f of x, or multiply it with themselves, perform operations on itself, and you attain new functions. Let's go back to the matter of composition of functions and solve a few questions. If g of x is equal to x squared plus 1 and f of x is equal to x over x plus 1, find f of g of x, g of f of x, f of x, g of x, and finally f of g of f of x. We can find all of these, so let's do the first one first. F of g of x, meaning that we are inputting g of x into f of x. So that will be x squared plus 1 all over x squared plus 1 plus 1. This will be f of g of x, and that's going to give us x squared plus 1 over x squared plus 2. Simple. Let's try and do the second one too here. G of f of x is simply inputting f of x into g of x, and that will be x over x plus 1 squared plus 1. This is going to be x squared over x squared plus 2x plus 1 plus 1. Simple. The next one is f of x. Recall that f of x is x over x plus 1. So f of x is going to be x over x plus 1, x over x plus 1 plus 1. Remember, we are putting the function anywhere we see x in the other function. So this is what we get. This is x over x plus 1 divided by x over x plus 1 plus x plus 1 over x plus 1. This is x over x plus 1 multiplying x plus 1 divided by x plus 1. This takes care of this and this takes care of this. You get 1 over x plus 1 f of g of x. You can take your time and go through the algebra. In due time, I'll bring a video on full algebra, so that in case you have a problem with algebra, you can go through it and everything will be successful for you. Let's solve the last question in this series. The last two questions actually. G of x. G of x. We recall that g of x is x squared plus 1. So g of x. G of x is x squared plus 1. So g of x is x squared plus 1 squared plus 1. So x to the power 4 plus 2x squared plus 1 plus 1. X to the power 4 plus 2x squared plus 2. Then the last question will be f of g of f of x. F of g of f of x. So it means you are putting g of f into f. So g of f this was a mistake. This was g So it means we're putting the result of g of f of x into f of x. Thus, g of x alone is x squared over x squared plus 2x plus 1 plus 1. And we are putting it into f of x, which is x over x plus 1. So this becomes our x, all of this. So f of j of f of x is going to be x squared over x squared plus 2x plus 1 plus 1 all over x squared over x squared plus 2x plus 1 plus 1 plus 1. You can leave your answer in this one. Nobody has a problem with you if you do this. Let's solve a few questions on our own and bring the lesson to an end. You can pause the video and solve this, then later check the solution. The solutions to the problems, you can look through and see if you had them correct. If you didn't, try and get a solution. You can rewatch the video and see if you understand the problem or go through the steps and find the errors. Thank you for watching this video. See you in the next one.